Welcome back. Have you ever written a SQL query so bizarre that you feel like you are Tony Stark and you just invented time travel? Or maybe the other side of the coin and you feel like you just opened Pandora's box? Don't worry about it. We have all been there. One moment you feel like you're MacGyver stitching things together with duct tape and the spring from a pen, and the next you are wondering if you have crossed over to the dark side of databases. Today, we are going to dive into exactly those types of situations with some quirky SQL solutions. Some are crazy good tricks that will save your bacon and your career, and others, they might just be the kind of hacks that drop you quicker than a misused delete statement. Yes, we will talk about that little Bobby Tables incident really soon. So, grab your beverage of choice. I've got my coffee right here, and let's talk about those SQL oddities. The ones you should use and the ones you should never use. All explained plain as day with a dose of maybe a little bit of nerdy humor. By the end, you're going to know which of these quirky SQL tricks are your secret superpower and which ones belong in the villain's league of anti-patterns. Let's jump in. All right, here's one that we've talked about before. Where 1 equals 1 trick. This is the always true helper, right? Have you ever seen this where 1 equals 1 and thought, why is this even here? This doesn't make sense. Don't worry, it's not some Illuminati code. The condition 1 equals 1 always evaluates to true. So on the surface, it really does nothing for the query's logic. So why use it? Simple. Convenience, especially when you are using this for programming. So you're maybe building some type of dynamic SQL using some parameters. You're starting your where clause with a condition that's always true. And so that way you're freely able to add on some and logic to that without any type of issues or having to check and see if there's already part of a where statement there. So it is like, again, putting a dummy item in a list so that every real item can easily be appended to. This is especially handy in application code, like I just mentioned, that builds queries on the fly based on user input. So for example, we have this code. So we have select all from employees where 1 equals 1, right? And again, I've got this note in here letting you know that it says that it's always true. It acts as a placeholder, and now we could dynamically add filters. Imagine that, these two conditions right underneath here, the department and the hire date, get added on dynamically based on some type of programmatic flow that happens. Maybe you're using a Power App and that criteria is being added to the query back to the database. It's very similar to having your commas at the beginning of your row, at the beginning of each row before your field name, and it makes it easier to comment out, right? So it just makes life a little bit easier. It's like a QOL, right? And quality of life type upgrade. So bottom line here, where 1 equals 1 won't improve the performance. It won't harm the performance. The optimizer really just ignores it, but it will improve your sanity when it comes to dealing with dynamic SQL strings when you need it most. Otherwise, it really is a harmless quirk that you may see from time to time. Next, let's take a look at generating data on the fly. So cross joins and recursive CTEs. Have you ever needed a quick sequence of numbers or dates in your query without without a numbers table on hand or without a date dimension on hand? Here is a quirky but awesome trick. You could use a cross join or a CTE, or which is a common table expression, to generate a set. For instance, in Postgres, you really have this handy function called generate series, but in standard SQL and other databases, you have to simulate that. You don't have that function. The idea is to take a small table or even a subquery that returns a couple of rows and cross-join it to itself multiple times to produce a bunch of different combinations. This yields a sequence of numbers that you could use for testing or filling in gaps where needed. For example, to get numbers 0 through 99 without a table, you could use this script. So we are starting with a CTE, we're naming digits. So we're saying select 0 as D, you're unioning it to 1, then 2, and so on and so forth until we get to 9. And then we are selecting the ones digit plus 10 times tens digit as number, and then from the digits, and you could read the query here. But then we're doing the cross join with the digits CTE that we just created, and then we're sorting it by that number. So again, it does a great job of being able to just go through and kind of recursively create a whole list of numbers. So this quirky query really uses two sets of 0 to 9, 1s and 10s, and then cross joins them to produce 100 different records, right? 0 to 99. It's like Lego for SQL, right? Simple parts snapping together to form something bigger. You can extend the idea, you could join more times, or again, use a recursive CTE to continue to loop through these to get larger and larger sequences. When would you practically use this, right? It sounds like something that's a great theory, great thing, that interview question, but really practically, when are you going to use this? So let me tell you, if you're generating test data, that's a great example for needing something like this. Creating a calendar table on the fly is another use case. Any scenario where you need some type of quick row generator without permanent tables, this is a clever hack that shows off SQL's set of Legos and logic in a fun way. Just remember, cross joins multiply rows. So keep the base small. 10 times 10 is 100, right, in our example, but you don't want to make this too big. Don't go cross joining a million record table with a million record table. It's gonna spin up your compute, and somebody is gonna come after your head. So don't go cross joining to infinity, or you are gonna crash faster than a poorly indexed join. So next, we're going to talk about conditional aggregation, and this concept of pivot tables with case statements. So sometimes SQL feels a little bit rigid, right? In Excel, you could easily just highlight a table of data, hit create pivot, and you quickly have a pivot table, right? And you could make it dance. But you could do the same thing with very similar thing with SQL, right? This is a bit of a trick that really will help you to make SQL dance as if you're the puppeteer. So a favorite quirky yet useful trick that I have is this conditional aggregation. So you'll see this from time to time. You could use a case statement inside of aggregated functions. So think of it as a DIY pivot or a multi-conditional summary without having to write a bunch of separate queries or subqueries, right? For example, suppose you want to get a single query to count how many employees are in each department and how many are in each job role. So in one result, and you want this all in one row, right? You could do this by combining a aggregation of sum with a case condition. So for example, we have this query where we are selecting and we're using our select statement, right? And then we are using the aggregation of sum. And within each of these sums, we have a separate case statement. So the first one we're looking at for when the department is sales, then 1 else 0. Next, we're looking at if the person's in engineering, then 1 else 0. And then for the roles, if they're a manager or a developer, very same concept. If it's true, then 1 else 0. What this is doing, because a sum of 1 for each of the records is the same as counting the records, this is counting each of the records where this case is true. So it's kind of a trick here. We're using that case statement to return 1 for the rows that match that condition, and the sum adds them up. So again, it effectively gives you multiple specialized counts all in one go. It's unconventional because we are piggybacking on the fact that sum of ones really, again, is the same as the count of the occurrences, but it works like a charm. This trick really can be extended to sums tables of values. Even if you have some complex case statements, some complex grouping that you need to create, you could use this particular trick, right? So you could extend that case statement far beyond the simple case statement that we have here. So it really can be extended into a lot of different aspects here. So you could do things like the sum of sales only for specific regions, or again, even more complex logic. So why is this quirky good? Why is this chaotic good? It keeps things set-based and efficient, avoiding multiple queries or application side processing. It really can make your SQL look a bit like you're casting spells. Right? It really is performant when properly indexed, and often easier to maintain than a bunch of separate subqueries that you may have to write otherwise. So use this to impress your coworkers during the next stand-up, and maybe drop a Doctor Strange database wizard reference while you're at it. All right, next we're going to talk about window functions and the mysterious lag versus lead. If you have really gotten into window functions, you know that they could feel a bit magical at times. One quirky but awesome use is really finding values from other rows without a self-join, right? So often, in order to get the values from different rows, you have to do some kind of self-join, and could be really not performant. So say you need to compare each month's sales to the previous month's sales. The conventional way to do this might be a self-join, right? On month equals previous month, which is kind of clunky. Again, can be kind of not performant. So enter lag versus lead, right? These are window functions that let you peek at another row's value from the current row's context. So for example, we have this query where we are looking at the month and then the sales, and then we have the lag function here, the window function for lag, where we are looking at the sales over the order by month, and it is for the previous month, where the lag, it takes the field that you want to look at and then the number of rows before or after the current row. And so that's why we have the order by month, to let it know we want that month is what we want to look at the previous one of. So again, it gives you the sales for the previous month, and then this next one, we're taking the sales minus that lag, and again, that way we kind of get a variance, right? So this is a common scenario that you have for sales groups. They want to know month over month what's the variance between the current month and the previous month. So this is an important piece, right? So now in each row, we have the lag is pulled from sales from one row back. Again, that's the one that we have there. And according to the order by month sequence. Now you have the current month and the previous month side by side. And then we also have that variance that we just talked about. No self-join needed, no subquery. It is just a easy to read, easy to maintain window function all in one row. It might seem standard if you've used window functions before, but to those of you that are new to window functions and new to SQL, this might seem like some type of advanced SQL sorcery. All right, let's talk about when a clever SQL trick goes horribly wrong. All right, take a deep breath and maybe a sip of that coffee. It is time to venture to the dark side of quirky SQL. These are some of the ideas that sound really clever at 2 a.m., or maybe that you found on this sketchy forum that you went down a really deep rabbit hole to find, but they will come back to bite you hard. You might get away with using them once, but you do not want to be the dev on call when things go haywire. Let's proceed with some caution and some humor, and make sure you actually never use these in production. The first one is the quirky update that I referenced to a moment ago, that black magic for running totals. So our first villain is actually really famous in SQL lore, the quirky update. Even the name sounds like something out of a D&D campaign. This used to be a hack for calculating a running total or a sequence in SQL Server before window functions ever existed, so it's been a minute. It really involves updating a table when using a variable to carry over calculations from row to row, all within a single, really gnarly update statement. So something like this, for example, the quirky update for running a total might look something like, this, where we're declaring our sum. We're starting out with an integer, right? And we're saying it's 0. And we're going to update the transactions table. We're going to set that sum equals the balance, which equals the sum plus the amount. And so that's going to go through and basically provide a running total for each of the rows. Believe it or not, this actually updates each row's balance as a cumulative sum, because the variable sum preserves that state across the rows during the update. It feels a little bit like dark magic, and it kind of is. Why is this bad? Because it relies on really some undocumented behavior of how the SQL engine processes the update. There's no official guarantee that it will always work the same way and go in the same order, unless you add some hacks like an order by in the subquery, and even that could be a little bit dicey. It's basically really bending the reality of SQL's engine arm to do something in a specific order, which violates SQL principle that tables have no implicit order. While it might work in some versions or some small test scenarios, especially with scale, as your data scales, it will break as the optimizer changes, or again, if you change into different environments. And when it breaks, you will be debugging a really weird issue, especially if you've handed this off to somebody that has handed it off, and maybe that person's inherited twice. That person's gonna be lost. So the modern solution is to use the window function, right? You could use sum over and, for running totals, right? And which is so much more reliable, so much more understandable and readable. And let's let that quirky update retire as a party trick from the early 2000s. Do not use it in your new code. If you see it, refactor that code immediately. It is really a chaotic evil solution that belongs in the history books, or maybe a evil villain museum. So next, we're going to talk about how people use select all everywhere. This is the wild card of doom. So, hey, why list all the columns when I can just do select star? It's so efficient. Said no experienced developer ever. Using a select star might be okay for some quick ad hoc analysis or querying, but it is like the One Ring in Lord of the Rings. It is tempting and convenient, but incredibly dangerous. Why? Let me tell you. It can create some unpredictable schema changes. If somebody adds or reorders columns in a table, select all will start returning those changes without any notice. Conversely, if you use select star in a view that you've created, that view is going to break if somebody adds a new column to the source table. So there are some inherent issues with using select all in various aspects of your SQL. So, again, the one that we talked about right here, your app might misbehave or break because it wasn't expecting all that extra, new columns that just got added. In addition, it could create some performance issues. You're returning a bunch of data that you don't necessarily need, right? Other tables have columns like big blobs or verbose text that you don't need in that task. Unnecessarily moving more data and utilizing more memory than is needed. It is the SQL equivalent of grabbing the whole library when you only needed one book. Not very efficient. So using select all all over your code base is really a ticking time bomb. It is going to start to slow down your application, start to slow down your analysis engines. It is quirky in the lazy, chaotic sense. So really resist the urge to use this. Explicitly list out the columns you need, please. Your future self and your application is going to thank you. In short, one does not simply select star without facing the consequences. All right, so finally we're getting around to the little Bobby Table's tale that we've been referencing all through the show. Let's talk about this dangerous, quirky practice that sometimes you may still see. Constructing SQL queries by simply concatenating a bunch of strings, especially with user input. It is quick and dirty and maybe can be used when you are testing things, but why bother with parameters or elms? I can just do SQL equals SQL all from users where name equals and then whatever gets fed in from the user parameters, right? Don't do this. This is setting yourself up for a common cybersecurity issue called SQL injection. So this is how you invite the famous little Bobby tables into your database. You know, that kid from XKCD comic who is named Robert, drop table students, and Rex Habit. In case you haven't met him, here is the full story. Yes, it is a funny comic, but the lesson is serious. SQL injection is no joke. People have used these types of vulnerabilities to, again, drop tables in databases, delete tables, insert users into user tables so that they can access your database with those new credentials that they've created themselves. So when you build queries by concatenating these unchecked inputs, you're basically just opening your doors and saying, hey, hackers, come on and screw with my database, right? It is one quirky shortcut that will destroy or your data or leak sensitive information in a heartbeat. And it is a road to unemployment. While concatenating strings to build SQL might seem like a clever shortcut, and yes, we all did it at the beginning of our careers and quickly learned better, it's a habit to drop like a hot potato. In our quirky alignment chart, this one is solidly in that chaotic evil section with a capital E. Avoid it at all costs, or your next pop culture reference might be you, starring in SQL Injection, the horror movie. Remember, just because something works doesn't mean that you should use it. In doubt, ask yourself, what would Bobby Tables say to his mom about this? Or, on a lighter note, I hope that you got a laugh or two out of this script today. I tried to make it entertaining and fun and throw in some nerdy humor. Let me know down in the comments, what is the weirdest SQL trick or anti-pattern that you've come across? Did you use it or did you refactor it and get rid of it? Share your stories. We've all got a scar or two from the SQL trenches that we have fought in over the years. I would love to hear yours. If you've enjoyed this quirky SQL adventure that we went on today, don't forget to like this video and share it with your friends. And be sure to subscribe for other data engineering tips and tricks as we continue to prepare you for your data engineering career. Thank you so much for hanging out with me. Be sure to show up on Friday nights at 10 p.m. Eastern for our live video sessions. Thank you. Have a great week.